Hey guys, so today we are going to look at a topic. It's called free body diagrams. Now, what is this free body diagrams? Is something you probably have seen last year in 8th grade. Now, the reason why I'm talking about free body diagrams here is it helps us understand the whole topic of force much better. Okay, like we've done this laws of motion chapter now, and we've seen a lot about force acting on an object, creating acceleration, momentum, all of these things are there. And we also came across this word net force. So to understand this whole topic of net force, why we have to say net instead of just force, it will be a little more clearer if we are familiar with free body diagrams. Additionally, you might come across sums that ask you for finding a free body diagram. So if you do get a sum like that, then you can first finish the free body diagram. So we'll go through it and we'll try to look at some questions that you might encounter also for this topic. Okay, so for example, some questions would be simply diagrammatic. Okay, so you'll have an object like this. Will be some object placed on a floor or a surface. This is your body. Okay, not your body, but it's a body, right? So in physics, any object is called body. So this object will be shown to you as something having different forces acting on it. Okay, the force can be anything. It can be a person pushing it, someone pulling it, it can be gravity, it can be normal force, friction force. It doesn't matter what the force is. What matters is how many there are and in what direction they are working. Okay, so I'll give you an example over here simply. Assume that this object has one force. Okay, I'll say F1 is nothing but 10 newtons. We know Newton is the unit of force, right? So I'll say that there is one force on this object of 10 newtons that's pushing in this direction. Okay, it's acting on the body in the right direction. Right? I'll say another force F2 of some, let's say, 5 newton is acting on the object in the opposite direction, up towards the left. Okay, so just imagine a body or an object being pushed on two sides by two different forces, one bigger, one smaller. Now the question is, will the body move, and if it moves, in which direction will it move? Okay, for that we need to find out what is the net force. Okay, now how do I find this net force? Simply the sum of all the forces acting on that object. Alright, now you start off the sum by picking any one direction as positive, okay, and the other direction as negative. Okay, so I'll assume that for this case I'll say right is positive. Okay, any force acting in the right direction is positive, so left will obviously be negative. Okay, now first I'll write which force is acting. F1 is nothing but 10 newtons, right? Now along with the number I need to write a direction. First force is pushing in right direction. Now right direction for me is positive, so I'll write it as plus 10, or I just simply leave it as 10. It's a positive number. Okay, now I'll come to the next one, F2. Okay, it is 5 newtons. But if the direction is opposite, it is left, which is a negative. So I write minus 5 Newton. Okay. Right now there is only two forces. So net force is nothing but we write as F net equals to F1 plus F2. As simple as that. Okay. What is F1? 10 plus F2, which is nothing but minus 5. Plus of minus is minus, right? So 10 minus 5. Just 10 minus 5? 5 newtons. So net force is 5 newtons. But this is an incomplete answer. How do I make sure it's complete? Force has magnitude and direction. Okay, size and direction. Size we can find from the number. Direction we need to find using the symbols. Now which symbol does my answer have? Plus or minus? Right? If you see there is no symbol, that means plus symbol. Right? So I can say net force is 5 newtons acting in the plus is right direction. In the right direction. Okay. I can even change right left as east west, depending on what the question asks. Okay. So net force is nothing but 5 newtons and direction is positive direction. This is a very simple sum on free body diagrams or net force. Now your sums usually won't be like this. They'll have like 3, 4, maybe 5 forces acting together. What you need to do, you need to make sure you're looking at the arrows and the size of the force very carefully. Okay, I'll give you another example of a sum like this. Okay, we'll take a free body diagram. Okay, now watch carefully. Okay, so I'm telling there are 4 forces. Alright, I'll say this is 30 newtons, 15 newton, 10 newton, 20 newton, something like that. Okay, so I know that there are 4 forces acting on the object. Again, I can take any one direction as positive, negative. Choice is ours. Okay. Again, I will take the same, right positive, left negative. Okay, I will take the same, right positive, left negative. Okay, so how do I find out net force for this object? Again, same way. I'll start with listing the forces now. First, you can number them in any way. It doesn't. If it's not mentioned in the sum, see the difference. Name not given, you can name it as per your wish. Doesn't really matter. Okay. Now I'll start from here. I'll go like this in a clockwise manner. So F1 is 30 newtons. In the now look at the arrow. It's pointing right. So that means it is positive value. Okay. Next I'll come to this one, F2. This is 15 Newton, but it's pointing in which direction? Left, right? The arrow is pointing towards left. So I'll say minus 15 because left is. minus. Same way, F3 is 10 Newton. Again the arrow is pointing left, so minus 10 Newton. Finally the last one, F4 is 20 Newton. Now look at this arrow carefully. It is also pointing in the left direction. Although I wrote it on this side, it's pointing in this direction, right? It's not pointing towards right. That's what you need to keep in mind, the arrowheads. Okay, be careful. So this is also minus 20 Newton. So now I have all the 4 forces listed down. All that's left to do is add them. So F net is nothing but F1 plus F2 plus F3 plus F4. It's nothing but 30 plus minus 15 plus minus 10 plus minus 20. That is 30 minus 15 minus 10 minus 20. Okay, so if I simplify this, 30 minus 10 is 20, 20 minus 20 is 0, the remaining is minus 15. So if my net force is nothing but minus 15 Newton. How will I write this as a statement? I'll write net force is 15 newtons in direction. Alright, minus means left, so I'll say in the left direction. Alright. The object will always move in the direction of the net force. That is why the direction is important. Meaning, this block, when moved by these two forces, is definitely going to move in the right direction because this force is bigger than this force. Same way here, the force acting in right direction is less, but the one acting in left direction is more. That is why ultimately 15 Newton in the left direction is the final answer. Okay, that's why the direction is important, to tell which direction the object is going to move. Alright, so it's a very simple topic. It's this free body diagrams. Like how we have seen left and right, we can also do up and down. Okay, so you can probably try an example. I'll give you one right here with up and down instead of left and right. The matter is the same, right? We take one as positive, one as negative. Alright, so I want you to try this sum out. Alright, this sum, the answer to it, you could post it in the comment section. Alright, this won't be in your assessment, it's a separate question altogether. It's a very simple thing, so I hope you followed, and I'll see you guys in the next class.